All right, guys, sorry about the technical difficulties this morning. Today we're talking about graphing quadratic equations in standard form. And if you recall from August and September, when we looked at polynomials, this is standard form. Y equals ax squared plus bx plus c, where a, b, and c all represent numbers. Okay, so when you graph quadratics, you're going to get what's called, the shape is called a parabola. And when a is greater than 0, it's going to open up. It's going to be basically a smiley face. And if a is less than 0, it's going to open down, and that's going to be a frowny face. Okay. So every parabola has a vertex. This is either the highest or the lowest point on that parabola. So this one, the vertex would be here. Okay. And then every parabola has a minimum or a maximum value depending on how the graph opens up. If it opens up, you're going to have a minimum. If it opens down, you're going to have a maximum. Okay. Every parabola has an axis of symmetry. It can be found using the equation x equals negative b over 2a. You're going to come back to this a lot in your for your examples and for your homework. You're going to have to basically memorize that. This tells you your x value of your vertex. Okay. It's also going to tell you where your axis of symmetry is. Okay. So to graph a parabola in standard form, number 1, find the vertex. Plot 2 points on both sides of the vertex and then connect the dots. Okay. So let's try 2 examples. All right, well, first thing, after you find your x value using this formula, to find the y value, you plug in your answer back to the equation, and I have kind of a shortcut for that as well. Okay, all these notes are online. Let's do some examples. So if you look at your examples on your notes, we're going to look at example 1. And this says y equals x squared minus 8x plus 18. To find the vertex, it's going to be x equals negative b over 2a, right? But you need to know what a and b are. So you have to look at this equation. A is going to be 1. There's technically a 1 there. So a is going to be 1. B is going to be negative 8. And c is going to be 18. Okay. So when you plug that in, make sure you use parentheses too. So there's a negative already built into that formula. So it's negative and then parentheses whatever your b is. Our b is negative 8 over 2 times a. A is just 1. So let's simplify that. A negative and a negative make a positive, so that's positive 8. And then 2 times 1 is just 2. 8 divided by 2 is 4. So that tells you that the x-coordinate of your vertex is 4. That also tells you that your axis of symmetry is at x equals 4. So what you can go ahead and do is make that axis of symmetry. Okay. Now, based on what we have here, a is 1. A is greater than 0. Actually, should it be 1? Yeah, a is greater than 0. So that means your graph is going to open up. And something you can do, just looking at this equation before you even graph, you can say, okay, a is 1. I know it's going to open up. Make a little sketch. I know it's going to open up. if it opens up, that tells us that it's going to have a minimum. And you have to be able to know where that minimum is. So we have to find our y-coordinate. All right, so my trick. Whenever you have these kinds of questions, and this can work in Desmos too, you're going to go to your calculator. You're going to hit the table button. And we have x squared minus, what is it, 8x plus 18. Okay, so you know that the x-coordinate of your vertex is 4. So when you hit enter here, you want to start your table at 4. That is automatically going to tell you the y-coordinate of your vertex should be 2. So your vertex is at 4, 2. 4 up 2. Your vertex is there. And you can't see. Sorry. So that is my vertex. All right. So that is going to be, our minimum is going to be at that y value, which is at 2. All right. So we're going to get 2 points to the left of our vertex, and we're going to get 2 points to the right of our vertex. Our vertex is at 4, 2. So let's go here. So a point to the left would be 3, 3. And then another point, we keep going up. So that's going to be 2 and 6. So 2 up 6. And kind of a shortcut here, this is your axis of symmetry. So if we were 1 unit away on the left, you should have a point 1 unit away on the right. Okay. And then same for here. This is 2 units away on the left. We're going to count 2 units away on the right, which is right there. So let's check that out and make sure. We should have a point at 4, 2. We do. And then we should have a point at 5, 3. Sorry, 4, 2 is your vertex. Don't listen to me. 4, 2 is your vertex. 5, 3 is this point here, and then your other point should be at 6, 6. And yes, we have that. Now we get to draw. This is not a V, this is a U, so make it a U. It's going to be rounded down there. And then when you do that, point your arrows up. For these equations, your domain is always going to be all real numbers, which is negative infinity to positive infinity, because it can be any of those x values. The range is going to depend on a lot of things. It's going to depend on your minimum, the y value of your vertex. So let's see, if your minimum is at 2, that's here, y values start at 2 and they go up to infinity. All right, so the range is technically going to be 2, infinity, and the 2 gets a bracket because it can equal 2. Okay. End behavior is easy. As x decreases, just look at the ends of your graph. They're both pointing up, so both of these are going to be increases. Okay. The y-intercept, go to your table, find where x is 0. Your y-intercept is at 0, 18. Okay, we're going to do one more example, and then you're going to try the other two. All right, so let's look at number 2. Okay. Okay, so first things first, let's figure out what A, B, and C are. A should be -1. Let me write this in so you can see it. Your equation is y equals -x squared plus 4x minus 2. A is negative 1, B is 4, C is negative 2. So we know that we can do x equals negative b over 2a. Remember that negative's already built in. Don't forget about it. So that's negative parentheses, whatever your b is. Our b is 4 over 2 times our a. Our a is negative 1. So negative times 4 is just negative 4. 2 times negative 1 is just negative 2. Negative 4 divided by negative 2. A negative divided by a negative should give you a positive. So that's just going to be 2. So the x-coordinate of our vertex is 2. That means your axis of symmetry is at x equals 2. Okay. Right there. Okay. Now we can fill in a few more things. A is negative 1. So that means that this is going to open down. It's going to be a frowny face. And because it opens down, you're going to have a maximum. And the maximum is going to be whatever your y value of your vertex is. So let's figure that out. Go to your table. And our equation is negative x squared and then we have plus 4x and then minus 2. And be careful when you're plugging this in. Some people, they'll type this negative instead of the minus, and your calculator will not do that. So be careful there. Okay, now hit enter. You want to start, remember my trick, we want to start our table at 2, whatever that x-coordinate is. If we start at 2, that's going to automatically bring us to our vertex, which is 2, 2, which means your maximum is at 2. All right. So this is our vertex. We have 2, 2 right here. Right. So the domain is going to be all real numbers, which is negative infinity to positive infinity. And let's scroll down to in behavior. Just based off our little bitty sketch with the frowny face, you can see that both arrows are pointing down. That means both of these are going to be decreases. Okay, so now let's plot our points. Remember, we want 2 points to the left, 2 points to the right. So looks like we have 0, negative 2. And then looks like we have 1, 1. So if we did that correctly, we should have a point here at, what is that? 3, 1, do we? Yes. And then you should have a point. So that's 2 places to the left. Let's count 2 places to the right. Should have a point at 4. And then that looks like negative 2. Yep. Okay. So now make your curve or make your parabola. Oh, please do a better job than me. You get the idea. Mine aren't perfect. So now, based off this, you can figure out your range. So, range is going to be y values. So if we look at this, our y values stop at 2. They start at negative infinity and they go up to 2. So that's going to be negative infinity, comma 2. 2 gets a bracket. Your y-intercept, well, it's right here. We've already found it. It's at 0, negative 2.